Okay, good morning. Good morning. This is the Cosmology discussion group for March 30, 2025. My name is Harry Ricker, and I'm going to give a brief discussion presentation this morning to start things off. I sent out some videos and some material to stimulate discussion, and so people could ask questions, but I didn't get much of a response from that. So I put together a little presentation, mostly focusing on yesterday's presentation by James Arathoon. And I thought he didn't really make his points as effectively as I thought he should make. I have read O'Rahilly's book, Electromagnetics. I had the old version. I don't have the new version. And some of the things that James said were kind of interesting, but I don't think he really captured the main thrust of what the book was about. Although, Ian, I think you made some very good comments, which is it's not a book that you read from one end to the other. You kind of have to pick out parts of it. And it's more I'm interested in this subject, and you go to the chapters that discuss that subject and sort of read about that. But anyway, I'm going to see if I can remember how to do this. And okay, do we have you see my screen there? Yes, yes. Cosmology discussion, March 30, 2025. One of the points that James Arathoon said that I thought was really pretty salient to what dissidents talk about is he said something to the order of that physics has forgotten how to do physics. Does that sound, I don't recall. I tried to find the exact quote in the video, but I didn't have enough time to go through it. Do you remember what he said, Ian, about this?
We had some discussion. It might have been I who said there's such a difference between the classical physics, which was logical and mathematical and good grammar, and the modern, higgledy-piggledy stuff. Was that the part you're thinking of, Harry?
Yeah, well, he sort of summarized that by saying that modern physics has forgotten how to do physics, I think. And I'm not sure that that's kind of a really maybe more of a distillate of what he was saying. And I would have liked it if he'd have made that point a little clearer. So I sort of want to start off with that kind of comment. And I think, I'm going to sort of try to connect this all together to cosmology because of the crises in cosmology. They call them crises in cosmology. And I sort of viewed what James was saying and what O'Rahilly's book is about is kind of a criticism of scientific method and the way people are doing science. That's kind of how I kind of viewed his book. And it would have been more helpful, I think, if you'd read from the preface, which I think tells you a lot more about what the book is about. And from the preface, this is from the preface of Electromagnetics. He says, this book is intended to be an essay in constructive criticism. We don't hear that much anymore, much at all in science. I mean, they don't do constructive criticism. At least that's my kind of take on it. Existing expositions are freely criticized without regard for authority. Wow. I mean, that's really a bold statement, I think.
Which has no place in science, I think he said.
Exactly, which should have no place in science. I mean, this is really bold stuff. The arguments here urged are not put forward dogmatically, but rather for the purpose of awakening the teachers from their dogmatic slumber. Counter arguments will be welcomed by the author, but he proposes to pay no attention to mere contradiction on the part of the orthodox. I mean, that's kind of, we see that all the time, in dissident discussions, dissident arguments are rejected because the orthodoxy says this is what the truth is. Boy, that's typical when you run into discussions of special relativity. As originally planned, the work included a detailed criticism of the theory known as relativity, but the material became so bulky that publication of this latter portion has been deferred. So one of the things I think that James was going to do was what happened to this publication that he was going to talk about on relativity? Did he have notes? Have any of the notes survived the fire? I think that's kind of one of the things that he was. To me, that's kind of. I'd be interested to know what O'Rahilly, whether or not he actually did start to write a book on relativity or criticism of relativity, and how far he got.
It's not as bad as that, Harry, because there are two sets of archives. The one that was partially destroyed in the fire are the political archives in Blackrock College. The
Okay.
technical ones, which we haven't looked at yet, there's no fire there. They're in Cork.
Okay, well, that this his criticism of relativity, which kind of really interests me to know about. Although he does criticize relativity in the electromagnetics book, along with a lot of other stuff. I was really kind of excited when I heard that he was going to look in the archives because I'm kind of curious as to how much work O'Rahilly did on his criticism of book criticizing relativity. Well, I could go on. There's more. He says the history of electromagnetic theory is rewritten. So he's actually investigating classical electromagnetism, and he doesn't agree with the foundations. And that's kind of the key that I'm really trying to get at here in my little presentation. Okay, so I'm going to put O'Rahilly aside and go back to my presentation and say, basically, what we're talking about is a criticism of scientific method. Okay, I think O'Rahilly's book is a kind of a criticism of the way they're doing science. And I think we have to realize that this book was written in the 1930s. And probably the kind of science that he was thinking about how science should be done had already been passed by the time that his book was written. And so he's sort of writing a criticism from the older point of view, of the scholastic point of view, the scholarship, the point of view of a scholar looking at the history and criticizing how the theory was put together in the past that leads to the current ideas. And from my view of it, he's highly critical of the choices that were taken. Okay. And so I see that kind of as his book is sort of a criticism of scientific method. That's, of course, I like to criticize scientific method because I really don't see it's very convincing. For me, it's not very convincing. Okay, so excuse me?
I have a question. What aspects of the scientific method does he question? I mean, like the official scientific method or just the method that a lot of scientists take?
All right, that's a good question. I'm not, I have to give a whole presentation on O'Rahilly, I think, to really get to that. His book is really basically an attempt to do that. Is that kind of so?
Okay.
What I could do is sort of say, you can go online. I know that Ian went online and published a location. I think it's on the Internet Archive, and you can go look at his preface. I only read the first paragraph. There's more to it where he goes into more detail later, and he kind of gives you an idea of what he's talking about. Right. Does that help you?
Oh, yeah, sure. I'll check that
anyway,
out.
the point that I'm getting at and what I'm really trying to get at is the third point. In my view, crises and cosmology, they're talking about crises and cosmology. It's kind of hard to understand whether these are real things or just hype that's been produced to get attention and press coverage. So it's really
I think it's maybe height because there are disagreements in science all over the place, and maybe they just want to make it seem like a really big deal when it's just disagreements. It isn't a crisis. I wouldn't say.
Right. Well, I'm looking at it from the point of view, it's not so much a crisis in cosmology as a crisis in the method that they're using. And
Probably so.
I think the real issue is their method kind of has put them in a position where they're going to have these perpetual crises. And the method is you build a model, okay, a math model, okay, and then you call that the standard model. And I noticed that in cosmology they talk a lot about the standard model in cosmology, which to me sounds like they're trying to raise cosmology to the same level as the standard model of particle physics. Okay, so they're raising their science up to the level of we have a standard model, which implies.
I think it's useful, Harry, to distinguish two things in what is commonly called the standard model. One is the list of so-called elementary particles and the charts that we see all over the place, which is basically an attempt to summarize empirical observations from their analysis of all of these collisions. And so that's one whole area. The other area
now, my point of view is I don't really see that as their method. I see their method as they create a theory and then they try to fit the experiments to fit their theory.
Well, that's the problem. That's
or
the
their observations.
Standard model. The second part is the mathematical formulation, and there really isn't one. There is a selection of mathematical models which have been proposed, but there is no central model. So really the standard model is more, I think when we discuss it, we have to recognize there's these two parts of the subject matter. One is a list of empirical observations which led investigators to define a certain number of elementary particles in the charts that we've all seen, 3 generations of them. And the second is what we might actually call a model, which would be the mathematical structure defining the model. And there really isn't one. There is a very long Lagrangian, which is basically has many terms which are added ad hoc just to, we didn't think about this, so we'll add that factor into the Lagrangian and so forth. But it's really not an organized, structured model mathematically as such. So I don't.
Okay, so that's a good point, and I think you're correct there. And I think we may find this is true in cosmology. I think the same thing, and when we talk about cosmology and what they call crises, I think we're going to find out that there's a similar procedure. And so
I think you're on the right track there, sir.
I think that. So I say the current method is you build these models, and it's not necessarily clear, as you pointed out, that all the models, different models fit together. Okay, what you call the standard model, is it one big overreaching model, or is it a collection of submodels put together and called the standard model? I think that's what you were trying to say. Maybe I'm wrong about that. But
as far as the cosmology goes, we were just talking about this kind of analysis with the standard model of particle physics. But in terms of the so-called cosmology standard model, I think, as you I think are saying, there are really two parts of it. A collection of observations, which people have tried to put in various categories of this kind of galaxy, that kind of galaxy, and what have you. And secondly, some unifying set of axioms or principles which unifies everything, which unifies and explains or lends understanding to this collection of observations.
Right. Now, That's good. That's a good explanation of it. So, of course, now I'm raising the issue at the bottom here. Is this really a good way to go about doing it? It's become kind of the established way of doing things, and it's very technical. In my view, it's very technical because they're using computer models that are not really accessible. And I think because they're using computer models and a lot of experts, technical people who are involved in the computer modeling aspects. And I think these computer models are extremely extensive. And that explains, I believe, why you have hundreds of authors on these papers. If you look at these papers, you'll see that the title page and then all the way down to the next page, it's nothing but all these authors that are co-authors and co-authors of this paper. And I don't really understand why there's so many co-authors unless you have to include all these people that are doing subtasks and running computer programs and as part of all these subtasks that go into this big computer calculation that they're doing. And you probably
or you can look at it as simply a power play. There's a small minority of principal investigators that control the money are attempting to corral a large number of co-authors, so-called participants in the work being published, to in effect prevent any independent thought among all of these, dozens or hundreds of co-authors.
Well, I think I think the money motive is pretty strong because all these people, I think, are operating under grants from the National Science Foundation in the United States or other granting agencies.
But we're really talking about a crisis in current scientific method. The crisis in cosmology is a crisis in the current scientific method, which you're talking about now. I mean, the scientific method that we've applied to cosmology and other parts of natural philosophy for the last 2,500 years has been pretty successful, I would say. It's really the problems arose maybe, over 100 years ago, quite recently.
Right. Well, here's what I'm trying to get at with this slide is what is a crisis in science? And we have a specific example that we're talking about is what they're talking about making a big deal out of is a crisis in cosmology. And Sabine Hassenfelder in one of her videos sort of makes fun of that by saying now she can break her alarm, can break the glass in her alarm box. Crisis in cosmology, ding, ding, ding. I don't know if you've seen that. So maybe that's kind of an overused word. What constitutes a crisis? That's one of the issues that she raises in her videos. Why does what is happening rise to the level of a crisis? And she says, well, it's because the author of this paper said so.
They have to throw in those ad hocs.
Right.
And that's the crisis. That's the reason for the crisis is because the observations that they make don't fit their model.
Right. That's the first point I've got here. The observations don't fit the model. So that creates a crisis. Okay.
Many crises. They've had to throw in dark energy because when I was a kid, it was just dark matter.
Right.
They had to throw in dark energy to explain the expansion. So, well, if hang on a second, if part of that dark matter is now dark energy and it's pushing things apart, shouldn't galaxies fly apart? No. Well, there's something wrong, totally, completely wrong with their model. And that is they lack the unifying force of the electric force, which is 10 to the 39 power stronger than gravity. And it sorts everything out and puts everything in its place and puts galaxies 90 degrees on their filaments. And people just don't see what's going on in cosmology, and they don't understand that if they just looked at it from a circuitry point of view, an electric point of view, it would all make sense.
Okay, so that's kind of the point that I'm really sort of getting at, which is the third point. The non-solution, their solution is to change the model to agree with the data, but they're really still holding on to their fundamental ideas. Okay, and what O'Rahilly is saying in his book, he's saying he's criticizing the fundamental ideas. Okay, and O'Rahilly is saying his method is to criticize the fundamental ideas, going back through the history of how we got to where we are, and looking at all of the things that went into the creation of our current thinking, and looking and criticizing at those. That's not what they do. They don't go and reevaluate the foundations of the model. They accept the model as it is. Okay, and then the O'Rahilly method would be to re-examine the foundational assumptions, if you will, and so that's what his book is about, and that's one of the things that makes it so difficult. Is because it's an historical assessment, and complicated by the fact that the mathematics that he uses is his notation is kind of unique to him, and I found it difficult to follow his mathematical reasonings because his notation is so unfamiliar. But that's a criticism of his book. But he's really trying to look at the foundational assumptions, and that's why you'll see he addresses a lot of different issues. He talks a lot about the historical development of the theory of electromagnetism. He also gets into the units and how the units became established. So it's a kind of a wide-ranging criticism of just this one particular narrow area of science, which would be electromagnetism. So he's criticizing the development. He's critical of relativity, and that's important because people don't really realize how the theory of relativity really radically changed the foundations of electromagnetism, and how that.
I was just going to say it's tied to electromagnetism incorrectly, by the way.
Well, that would be O'Rahilly's conclusion, I think. I think that's why he was going to do a book on relativity, which we never really got to see. And he does criticize relativity throughout his book. And approach to criticize the foundations and try to look for mistakes that are there, but that's not the current method, which is create a standard model, make extensive measurements based on assumptions used in the model. And I think that's important because one of the things you'll notice is they're assuming that the redshift is an indicator of distance. That seems to be essential to everything that they're doing. Yet I'm not sure that that's really true.
In certain conditions, it may be true, but ARP shows that it's basically a measure of youth of an object.
Right, but so it's easier to ignore ARP and just continue on.
Exactly.
Or even more fundamentally, whether it's concerned always with distance, the assumption, which seems to be gospel, that it's a Doppler effect all the time. That's the problem, which is not questionable.
Yes, and I noticed some of the videos, one of the videos that Vladimir referenced, we'll talk about this later, but anyway, their solution was to say that time is different in different regions of space, and that means that the rate of expansion in different regions of space is different, and that accounts for the discrepancies. And to me, that sounds very ad hoc-ish.
Sounds ridiculous.
It is stupidity on the highest order.
Okay, so I think we've covered this. You basically move the goalpost according to what the way Roger Anderton talks about it. So you move the goalpost, you change the parameters in the model, hoping that changing the parameters will fix things. And okay, so I think that's the end of my discussion here, of my introductory discussion.
Well,
and,
what you just mentioned about time being possibly different in different areas of the universe, this is a part of a tradition where, in special relativity, is basically an attack on the basic fundamental measures used in physics of kilograms, in the SI system, kilograms, meters, and seconds. That really these things can actually change, and so that this puts us then in a undefined area where nothing is certain, where you can say anything you want.
yes. Okay. And I guess what my point was at this juncture was we could sort of basically look at some of the things that they're talking about now, that they're calling crises in cosmology, and sort of see how their approach is, how they're using this approach that I just sort of summarized, which is adjusting the model and not going back and looking at the fundamentals, just adjusting the model. And that's their solution.
That's why they say there is a crisis, because if they had this open approach, we've proved what we thought yesterday is incorrect. Fine, let's look at the fundamentals again. But they're so sure of their fundamentals. They say these
Right.
things have been proved beyond measure by countless experiments, and there's a crisis now if we find one experiment which disagrees with them. That's what the crisis is, because they're not open to revising the fundamentals, as you had in one of your points there.
Okay.
And I think what Ian just said is a critical point, that many of the power brokers in what I call the physics cartel have basically rejected the idea that a theory can ever be eliminated or excluded by data. In the old scientific method, which I think Ian was promoting and which I agree with, if convincing data contradicts a basic theory, the theory should then be rejected. But people don't reject theories anymore. They just trot right along and forget about the fact that, in other words, there is no such thing as an excluded theory. In the old days, theories used to be excluded by evidence, but now that doesn't happen anymore.
Yes. I think the issue is that because they have so many parameters in the theory, they can change the goalpost, and move the goalpost by changing the parameters in the model. And that's what they're trying to do. And anyway, that's my thesis of it. And I put on the screen here, this was one of the more recent results. This is the Atacama, what they call the ACT, which is the Atacama Cosmology Telescope. And that's looking at the CMB, and this relates to the Hubble tension. Okay, because there's this discrepancy between the Hubble constant as obtained from the CMB data versus is obtained by other methods. And so what they're trying to do is saying, well, where do we find it? Where's our mistake? Is our mistake in the CMB measurements, or is our mistake in our other measurements? And so I'm going to go over this a little bit. And essentially, the Atacama telescope confirmed the age of the universe is 18.3 billion years. So they didn't find a mistake in the CMB method.
What is that based
on? That's a good question, and that has to do with looking at these fluctuations and the cosmic microwave background. And I talked a little bit about this in a previous presentation. And I think this has to do with the baryon acoustic oscillations, which they're measuring. And you see there are these fluctuations. Can you see here? There are these fluctuate. Here's the larger scale map is on the left. And you see there's these red, orangish, and blue areas. And then there's a magnification of it on the right. And so you see all these fluctuations. And the purpose of this telescope was it's a higher resolution telescope. So the spacecraft that they had been using, the Planck and the Hobie, I can't remember the names of them right off the top. Oh, WMAP, Wilkinson, named after that guy in Princeton. What was it? WMAP, Wilkinson. I can't remember the acronym. But anyway, the Atacama telescope is supposed to be higher resolution because it uses a bigger reflector lens. So in other words, it's a higher resolution telescope because it has a larger, if you will, diameter reflector for the radio reception. So it has higher resolution. And so they get higher resolution, but they come up with that the age of the universe is the same, 13.8 billion years old, that they got with the lower resolution, which kind of puzzles me a lot because I would have thought they would accomplish more with a higher resolution than, they would have discovered something different. And apparently they didn't. So that's not really a crisis in cosmology, is it? But it keeps the Hubble tension crisis. It sort of, because it means that the Hubble tension isn't resolved by the new higher resolution measurement.
Have they yet extended the age of the universe? I thought I heard someone mention that
26.8 they're looking at now.
No, it's 13.8 billion years. But this is based on the cosmic microwave background measurements.
No,
So
Harvey was getting at whether or not the new calculations of the size of the universe that are based on James Webb's observations.
I mean,
they're looking at 26.8 billion now.
Well,
is that official? Because
not yet. No, it's not official, but it's not official yet.
It seems that if they change their mind and change all these textbooks, that people would begin to doubt the Big Bang Theory at all.
Well,
there's
news. That's the whole point. You don't.
There's news reports stating that they're thinking about extending the age of the universe to 26.8. So I've seen that number bounced around a few times.
Cool.
Okay, can you see this? This is a picture of the telescope. It's this business around the big part around is shielding shielding against the side lobes, and the main telescope is, I believe, in the center. It's not there. It's kind of vague, but anyway, I don't know if people are really that interested in it. But anyway, the point is that they didn't really resolve the crisis by this particular method. Didn't resolve the Hubble tension issue. Okay.
I'm not comfortable. I'm not comfortable with sort of having a black box as to here we have these new observations of the cosmic microwave background, and suddenly we're changing the so-called age of the universe, and there's a black box in between that. I like to think more, if you will, mechanistically, or perhaps as an engineer. I want to know what's in the black box. I don't think we can really talk about a lot of this information intelligently. Don't misunderstand me there, but if we don't know what's in the black box. In other words, perhaps someone should whip up some presentation of telling us what's in the black box. You have whatever the observation is of the CMB, and bingo, we get a new number for the age of the universe. Well, there's a black box in between the beginning there and the end, and I'd like to know how that was calculated. What are the assumptions or basis for this data being observed gives us a new age of the universe. How is that done exactly?
I would suggest that you write an email to Sabine Hassenfelder and ask her to explain that, because that seems to be one of the things that these video people who like to report on scientific discoveries and crises and cosmology tend to neglect exactly that point. And my answer is I don't know, and I don't see that any of these people who do videos on YouTube or any of that actually provided an answer. But it has something to do with these baryon acoustic oscillations or something, which has to do with the fluctuations of the intensity of the microwave background signal. And here again, you have a theory where their model is saying that there's a fluctuation in the microwave background, and this occurred at a certain time in the past. And that to me is a speculation that there are these acoustic baryon oscillations. And somehow, based on these measurements that they're making, they do a fit through a frequency analysis of the fluctuations, and then they fit that to their model. And then from that, they come up with the age of the universe. And I agree with what you're saying, which is that whole process is theory laden. And since we don't understand it, we sort of have to take their word for it.
Well,
but also, sorry, I thought that the so-called tension that they talk about is between the two ways of calculating the Hubble constant and therefore the age of the universe. One is what you're talking about now, the ACT, the microwave background and the variation in that. The other is using the redshift data. So if that is true, all they're doing now with this ACT is they're more accurately, so they would say, evaluating the parameter from the microwave background. They could not, by definition, resolve the so-called tension, because it's the tension between that method, which they're now, using more accurately, so they say, and the other method from the redshift data.
Right. Well, correct. Now we're coming up toward the end here, so be careful. You're going to get cut off 1 minute.
Well,
right,
I'd actually thought that why they would extend the age of the universe, the main reason I thought was because of completely developed galaxies where they couldn't have possibly formed in that amount of time.
Okay, I'm going to talk about that later if we have enough time.
Okay.
Hence James Webb's observations showing galaxies formed in the soup period of the expansion.
Yeah.
Right, and that goes to another aspect of the assumption, which is you have a galaxy formation model, which is an assumption, and that galaxy formation model doesn't agree with the other models, the other part of their model. So the fully formed galaxies are appearing earlier than they're supposed to.
Yeah.
Well, supposedly the old-fashioned method is to look at the publication, and in the methods section, they're going to either describe in detail their method and or reference to some earlier publication which does that. And that's the old-fashioned.
And I think it's true that we have this issue about what is the model exactly. And I think that's getting down to the details, where you got those 100 authors, in these papers, and what is the contribution of each of these authors? I mean, the complexity of of what's involved here is extremely high. You got many authors, probably many different computer subroutines being combined together. Probably you have different guys working at different universities under different contracts, responsible for writing a particular subroutine in the computer model, and different other guys responsible for processing the data that comes from the measurements, and they are responsible for maintaining the databases and processing the data, and so you have all these different people involved, and these papers, in my impression, they don't really go into all the details. So what you have to do then is you have to go to other papers where each one of these authors may or may not describe what he's doing in his particular subtask. So anyway, that to me is very obtuse and hard to understand. All right. One of the videos, Too Late, starts off with the title Too Late. Has this scientist quoting, "We are in the business of letting the universe tell us how it works." Which I thought that was kind of funny, you know. Oh, the universe is going to tell us how it works. But my view is that's not exactly how they do things. They have a preconceived theory that they try to make the universe fit into. And I think that's really what the issue is. Are they really letting the universe tell us how it works, or are
ignoring data that is presented through new experimentation and new instruments just doesn't make sense when he says something like that. If you ignore certain data, how is the universe going to tell you anything? Right?
Well, yeah, that's the problem. And but you have different opinions about. I think the issue we talked about earlier, which is ARP's evidence being pretty much ignored, and you know they didn't go along with what ARP said. There's a whole lot of cosmology basically has focused in on this one particular way of viewing the universe.
Right. And I'm not talking about just ARP. I'm talking about star formation. I'm talking about the way stars are powered. They're all powered externally. They all get their power from the Birkeland current that they reside on. There's no nuclear engine going on inside a star providing heat and light and X-rays and gamma rays and all of that. That's all being produced on the surface and in the star's atmosphere. And they just don't want to relook at the model and reconsider.
Right.
It's
So
just mind-boggling.
we're back to O'Rahilly's method, which is going back and looking at the fundamentals.
Yeah.
And I agree. You know, if you go, I'm an amateur astronomer, and there's this guy named Fellows that has an astronomy channel, and his channel is a little prosaic, and he'll do things like, I'm going to talk about Betelgeuse today. Okay. And he starts talking about everything that's known about Betelgeuse, you know, and they'll say Betelgeuse is X number of billion years old. It's like 8 billion years old. So he says. And you go, how does he know it's 8 billion years old? Well, it turns out it's all based on a model of stellar evolution. It's not, they don't have any real knowledge of what the age of Betelgeuse is. It's all based
on their model of stellar evolution and formation, and how these stars use up this certain gas, and then they go switch to the next gas, and then they start switching to the metals, and then they can't, once they get to iron, they just explode. It doesn't make sense to me.
Yeah, I understand that. It doesn't make much sense to me too. But that's not what they're looking at. They're not using the O'Rahilly method of criticizing the fundamentals or reevaluating the fundamentals when they run into a discrepancy. That's not what the method is.
No, because their fundamentals are already set, and they're set in stone for them. And there's no questioning their standard models. And again, if you don't leave room for question, like I say, believe in something, but don't believe in it 100%. You have to leave room for new data and questions. There's always questions about a model. There's never been a perfect model.
All right, I'd like to move on here because this gets to this particular video. I do believe that I think Vladimir pointed it out to me. This is where he talks about timescape cosmology. Well, they talk about this big wheel galaxy, which is this big, massive galaxy. It's a spiral galaxy, which is well developed and supposedly as big as the Milky Way and the Andromeda spirals. Anyway, the point is this timescape cosmology, and this is where this non-uniform space expansion and non-uniform evolution of time theory comes into play. So their explanation of one of the explanations given in this video is that the time, the evolution of time for the expansion of the universe, or the rate of the expansion of the universe, is a local phenomenon. It's not it's the time is not the same for the entire universe. It changes locally. And their explanation for this is that it has something to do with these voids. The voids expand differently because the time and the space. Anyway, so that is an example of this ad hoc. So we got a discrepancy. So let's suppose that time isn't uniform throughout the universe, that it runs at different rates for different regions.
Well, according to special relativity, galaxies receding, extremely fast relative to each other. I mean, that would seem an explanation for time dilation, even though I don't agree, but that seems a possibility.
Well, that's why this is a plausible argument to make. That's why it seems plausible to them, because relativity has sort of created this idea that time in different places is different. And so the whole relativity paradigm allows you to have space and time are different in different places. So when you have a discrepancy, when your model isn't working correctly, you have a disagreement between data and your model, then you can go in and say, well, time has changed and space has changed. They're not really going at the same rate in different parts of the universe. And that it can explain this discrepancy. And that's kind of
now they're saying, I don't know if you've seen this, but they're saying that this time difference or time dilation is possibly the fundamental cause of gravity.
Right. Yeah. Oh, you can speculate on a lot of stuff here. Okay, so I thought that was kind of interesting. That kind of goes along with my theme, which is that's not the O'Rahilly approach. Going back and looking at the fundamentals. Maybe we made a mistake back in the fundamentals. No, it's like we adjust the model and we adjust the parameters of the model to make it fit our preconceived notion. Okay. Does anybody have any comments on that?
Well, also, as we had discussed in a previous Zoom session, that the galaxies that rush away from each other they must exceed way over the velocity of light, so that discredits special relativity right there. However, they say that it's the mystical warping and stretching space that accommodates that, which, in my view, space is an empty void which physical phenomena occupies.
Well, yeah, you could look at it from the philosophical point of view. I think the point that came out yesterday when we were talking about O'Rahilly and his approach. He, in his approach, and I believe that, and I think the point was trying to be made that it was Catholic philosophy was involved. Is that not correct, Ian? And
Well,
that's
at the end, yeah, I think I've forgotten who wrote. In the comments, I think some people were saying, "How many, so many eminent scientists coming out of Ireland, and what's the reason?" And I think Toby Grott said, "Oh, the mysticism or something in the past." And then we got to that, yes, and it might have been I who mentioned that the sort of like O'Rahilly would have been obviously from the Catholic, basis and the Gaelic ideas, and then you would have some of the other scientists who were mentioned would be more from the Protestant Anglo-Irish section. So there might be something in this. I don't know. I think
well,
it's
my
that
point on
O'Rahilly favoured this French scientist whose name I've forgotten, a very famous physicist, begin with D, Deutsch something, who seemed to conflict with Maxwell in some respects, and O'Rahilly favoured this Frenchman instead
right.
of Maxwell.
Well, the point I was getting at is that there's a different philosophical orientation. Okay, the Catholic school. I think the point is that O'Rahilly was a Jesuit, and one of the points was that his views were in conflict with, like say for instance, Lemaitre, who is also a Catholic, and that the way these scholars, Catholic scholars, viewed things was more of a traditional philosophical point of view. In other words, they had a foundational philosophy that they were analyzing things in terms of, which modern science doesn't really look at the way they do science through the lens of philosophy. It's just models and data. You see what I'm saying?
Yes. And I don't know if that's more a characteristic of what we might call an Anglo-Saxon philosophy rather than, sort of a continental one. In that respect, I would think that because of his training and way of thinking, O'Rahilly would be a bit nearer to what we would have called continental philosophy rather than Anglo-Saxon philosophy. I
Right.
might say that. Yeah.
I understand what you're getting at. That's a bit in the bit technical, I think. I think that's what Jerry was trying to talk about. He wants to proceed from a philosophical orientation, a fundamental philosophical perspective. And that's not really what I believe informs modern science. Modern science is informed by this scientific method, which is you build a model and then you test the model. And
Sorry, who was trying to say that? What did you say, Perry? I didn't get
Jerry,
that.
Jerry.
Oh,
Jerry.
Sorry. Beg your pardon. Thought you were
All
about
right,
something.
go ahead, Jerry.
Well, well, I, having trouble speaking. I would personally say that the scientific method itself was arrived at philosophically. I mean, whenever we formulate hypotheses, we're pondering, we're thinking, what's the possible cause of that, and that essentially is philosophical thinking. I mean, philosophy and science are very much intertwined, I would say. I mean,
Not anymore. That's my point.
science developed out of philosophy. I mean, science.
That's true. My point is that's not the case anymore.
Well,
That's kind
I mean, like some philosophies are
of,
definitely incorrect. That's for sure. However, though, there's still a philosophical approach, which is essentially questioning, like how do things exist? How can we find it out? Just critical questioning.
well, they're not doing that. That's my point.
Oh, yes. I mean, I agree that not all philosophies are accurate, for sure.
Well, that's not what modern science is doing. They're not doing what you described. They're not questioning the fundamentals. They're not looking at fundamentally different alternatives. They're looking only at changing the parameters in their particular model.
Yeah.
Exactly.
Okay.
See,
a good
the
one.
terminology which we come across every day, Harry, gives the lie to contention that science is open. They talk about it quite openly. They settled science. That's a contradiction in terms. That is
Right.
something that cannot be questioned. It's settled.
Right.
Or even the science, even the expression of the science, which you hear on the media every day. And
Okay.
therefore, if something comes up which contradicts that, yes, we'll have to change the parameters or fiddle around with it. But it's settled. It cannot be uprooted in any way.
Okay, I want to move on to Sabine Hossenfelder has a video that I sent a link to where she talks about cosmology crises get worse. I think that's the title of it. And she basically says there are four areas. One is the Hubble tension, and we talked about that. And then there's the cosmological principle. And I've talked about this previously when I talked about the cosmology. The universe is not uniform. It's not uniform according to the cosmological principle. The cosmological principle, which is the basis of general relativity, and they're making their general relativity model, is on the assumption that the universe is uniform and looks the same everywhere we look. And the point is that there are these gigantic, huge objects. So you have these big, giant structures, and then you have these voids. Okay, so it's not uniformly distributed. So there's a problem with the cosmological principle. And then we talked a little bit about this. There's the problem of the massive young galaxies. Okay, and that involves this thing where you have the timescape cosmology ad hoc, where, well, we can explain this if the evolution of time and space is different in different regions of the universe. That's just one explanation for it. There are others. Rather than going back and saying, maybe we made a mistake at the fundamentals, maybe somewhere along the line, we made an error. And I mean, it's kind of puzzling how a galaxy that is fully and completely formed and equivalent to galaxies such as the Milky Way and the Andromeda galaxy that we're very familiar with in our current epoch, how can, according to their theories, how could such a galaxy exist? That's a problem. No explanation for that. And then there's this sigma 8 issue that she mentions, which I didn't really quite understand, which is that there's not enough matter clumping according to the model. And I don't really understand why that was an issue, but perhaps maybe we'll know a little bit. So that might be, I just sort of suggest that people look at that to kind of get an overview. And the next thing is, Vladimir sent me a video that I believe Sabine did about extra dimensions, in which she talks about the compactification, where these dimensions are wound up and coiled up. And supposedly the idea is that this is supposed to explain the age of inflation. And these particles are supposedly wound up in these compactified dimensions and then create what she calls a tower of particles. And these get released really quickly during the period of inflation. I thought that was kind of, I don't really quite think that was particularly convincing. And so I guess what that means is they're still trying to explain or justify this inflation part of their model, which is kind of confusing in my view. I don't really see that it follows at all. There's another video that I was looking at, and I thought this was kind of interesting, where they're talking about there's too much energy being emitted by the nucleus of the Milky Way. And they're attributing this to dark matter, particles, self-annihilating. Does this sound familiar, Vladimir? And I thought,
I'll give you a comments later. Let's continue. Let's see all these, videos I sent to you, and I want to hear the ideas of our group, what we're thinking about it, and then of course I will give some comments about. I can
Well, I
give you the
thought this.
comments even about what you talked before. Let me tell you my opinion about this philosophy, about this science, about how it works. In one of your slides, you showed very important point. They're doing measurements based on the assumptions of standard model. What does it mean? They don't care about any other models. They are trying all the time to prove, to confirm that standard model does work. Simple like this. That's why all the experiments, from my point of view, they must be independent on any theory of any model. Please give me results and then only tell it fits to some theory or not. The second very important point, any theory must be based on dimensionless parameters if it's a real theory. It doesn't go with variable parameters. Standard model, there is no even one constant, maybe a gravitational constant, that's it. All the rest parameters, and it's over 20 of these parameters, they're matching any times for different experiments, that's it. What kind of theory it is? Let me remind you, even Maxwell equations we had based on experimental results that were done before Maxwell equations, before this electromagnetic theory, all this laws, they were measured all the parameters before the theory, and only then theory tried to explain experimental results independently obtained. And and now what we have very interesting situation. You have only confirmation based on experimental results as a confirmation of existing theory. That's a bullshit. Experiments must be independent. You must give some numbers without any connection to any standard model or not standard model. This is it doesn't work for me at all. I'm experimentalist from the beginning up to end, and I'm trying to do something based on experiments independently. Try to explain what they measured, parameters, and try to do something about the matching of your theory to measurements, not vice versa. You're doing measurements according to the theory. No, come on.
Right.
That's why it's
That's a good summary of it. They're doing measurements according to the theory. Their
yes, it's
theory
exactly my
informs
point.
their
That's why, guys.
measurements.
But you put in your slide, it was such line even. They are doing their measurements based on the theory. They are trying only to confirm, and that's it. It means there is no dissidence, there is no the different models, theories, and all this stuff. There are none. That's why And what is important? One more time, real theory must be based on some dimensionless parameters, like Maxwell equations. You have some parameters of that, and that's it. And you're trying to explain all the experimental results based on these parameters, constants, or something you put in advance, not matching your results, what you got today. And tomorrow, these parameters will be different. That after tomorrow will be one more different. What kind of theory?
The search for
Okay.
gravity waves, the search for dark matter, billions upon billions of dollars wasted. You're right, Vlad. You're right,
Okay,
Vlad.
guys, look, I'm experimentalist, but I'm trying to explain some experimental results obtained by astronomers. By the way, astronomers, they're doing great job right now, but they're not experts in astrophysics, and they're trying to explain their astronomical great observations based on non-existent theory, Big Bang theory. And that always there is some damage of logic even. I can't believe what's going on right now with physics.
Actually, the
That was
cosmological model, the way it is, forgetting about the Big Bang, the universe as it's observed today only takes gravity into account. It doesn't take any other force that is larger and more powerful than gravity into account.
okay. I'm going to disagree with that. They have this thing called dark energy that they've invented, which is, in my view, kind of an ad hoc, and that's
What
kind of
it's at home. And what is important, dark energy they invented, and suddenly it turned out to be over 70% of the energy density of our universe of my
Right.
group.
That's
It's
that's a
simple
major
like this, you know. They invented even dark energy to explain some experimental results ad hoc. I don't know what does it mean dark matter in their theory. 27% of dark matter, where it came from. There is no
yeah.
beginning. There is no any dark matter. There is no dark energy, and this is the main place of their model. Can we believe it? You don't know where
Okay.
they came from. Okay,
All right.
sorry for my
I
emotions,
want to
but I
I
try
want
to
to
summarize what we heard before. Thank you so much for very good presentation, but it's clear what is going on right now with the real physics.
Okay, I want to try to finish up a little bit, and then in the last session we'll let Jerry talk. Um, okay, so I brought up dark energy for a reason, because one of the new crises is that their measurements of dark energy are such that they are saying that dark energy is changing. It's not constant, it's changing. So they have this problem now that their model was that this dark energy was supposed to be constant, but now it's not constant, it's changing according to their measurements. So now they have to have an ad hoc in their model to explain why the dark energy is changing. And because the measurements don't confirm their model that dark energy is constant.
Who are they?
The scientists that are doing these measurements of dark energy using this device called the dark energy spectroscopic instrument.
Well, all of this discussion, we've been talking about they and them. And, I think what we need is names. Mr. Mills has theory A.
But you have a
Mr.
hundred
Johnson,
co-authors on these papers.
well, who are the principal
It's a
investigators?
good point. There
They,
is
yeah.
nobody.
So this is like some mysterious group that we can't name.
No,
Well, they're not mysterious.
they are the standard cosmologists and the holders of the holy grail of cosmology, the ones that say that the standard model is correct, and the ones that follow them too. Like,
Well, like who are the kingpins here? Who are the main names? Like we go back in science history a little bit, we suddenly have names. We have Maxwell. We
well,
have Faraday.
go to the heads
We
of each
have
department of each university, James.
what? Do
Go to
what?
the
Well, my
heads of
under,
each department of each university, and you'll find those people.
So
yeah,
our collective they is the chairmans of astronomy departments. Is that what you're saying, Rick?
And their underlings.
I think it's more of a net. I
I
think
would
it's more of
say
a
that they
network.
could be pinpointed by looking at NSF grants in astronomy and finding out the names of the principal investigators. That is your they, I believe.
yes, but the thing is, they've covered themselves with an extra 100 co-authors to essentially protect themselves, because it's a committee effort now. Science is a committee effort. It's not like the lead investigator, that's what they call him, the lead investigator or the lead author, co-author, the lead co-author. He's not the lead author, he's the lead co-author. And you've got 100 people on that are co-authors. And you're saying, well, that person ought to be responsible. And it seems to me the reason that they have 100 co-authors is nobody wants to be the guy responsible.
So maybe some of these grants should be terminated, like the.
Yeah, I don't. I just, to me that's kind of part of, to me that's kind of a disease, that you have 100 co-authors on a scientific paper. I mean, nowadays you see papers. There's just there you don't see a paper with one or two authors. It's 50, 125. It's always many more than one or two.
And you're right, Harry, and that goes back to Sabine's video about the email that she received from the one researcher that said, "Hey, it's not just me, it's everybody in my field and everybody in other fields, and science is rampant with fraud as far as I'm concerned."
And one might be even more cynical and say, well, they are subject to grants they're getting from agencies, and they have to justify all these extra staff that they're employing to the grant producing agencies. So they say, oh, we've produced so many papers. Those people that you're paying for, yes, they've published so many papers with us. So it's a bit of a PR exercise, actually.
It's kind of really hard to pin down, this modern way of doing science that doesn't. I mean, you could say Einstein's theory of relativity. You could say Einstein. He didn't have any co-authors, did he? And but the modern people, it's just there's co-authors and co-authors. Who is actually, I guess you have to dig into it to find it. I would assume the first author that's listed is the guy who's really responsible. But
So, guys, let me do some comment, and you will understand my point about what is going on. Do you know who killed communism in Russia? I will tell you who. We. There is no personal responsibility in any business. We are responsible. Who we are, we don't know. It's exactly what is going on right now with physics. We. There is no personal responsibility. There are no main guys who is doing this physics, who is responsible for any word in cosmology and physics in any place. It's very important to put this we 1,000 courses and then no responsibility for any of them. All of them responsible, and we don't know who is personally responsible for all this bullshit. You see, it's my comparison of communism and physics right now, the same stage, without any responsibility for any guy about what is going on with our cosmology, physics, and all the theories about.
I would
Simple
say
as this,
I
guys.
would say simply any scientist that adheres to the standard model and thinks it's set in stone, they're the ones that are they.
Personally, name at least one person who is responsible for it. I absolutely agree with James. It must be personal responsibility. I developed my model. I'm responsible for mine. James, you developed your theory. You're responsible for yours. Who is we? I mean, all of them, 1,000 of them.
I think it's
Who
more. I think it's more of a
personally?
It's more of a collective agreement amongst countless thousands.
Well, most of the people that have invented the standard model are dead, and the people that are the followers of that standard model are in high positions in the in each a university or whatever institution, and they perpetuate the standard model. They perpetuate the mistakes of Einstein and others. That's all I'm going to say.
But you're right about the collective responsibility. I mean, the popularizers of science,
Responsibility, collective irresponsibility.
yeah, okay, whatever you want to call it. But the popularizers of science say, we now know that this is the case, and we've developed this, and they don't say there's a school of thought even that has developed this sort of thing. It's like a consensus, and it's a collective, collective. Depending upon how you define the word responsibility.
Also, I think that
there is no responsibility. No.
I think the development of communications has also played a role in this, that it's easier for a small group of elites, if you will, those who are the principal investigators of various grant proposals, to exert control given the development of communications, of the internet, and so forth. I think that is a development which has affected science and how science is conducted, just the advance in communications technology. Well, that point felt like a lead balloon.
Oh, I would agree.
Thank you, Jerry.
All right, we got 4 minutes. Bob, we haven't heard from you. You're a philosopher. Oh, he's not saying anything.
Hey, hello. Hello.
All right, go ahead, Roger.
Okay. I'd just like to say that Einstein did have co-authors at the end of his 1905 paper on special relativity, says thanks to his friend Michael Bisso. So he wasn't really crediting his co-authors sufficiently. And there's speculation that his wife was one of his co-authors as well. So it's just not so far highlighted in the past at that time co-authors.
Right, but he was taking responsibility for he's taking personal responsibility unique to him. He's not saying we as a group are proposing this theory. It's my theory. My theory, me, Albert Einstein.
He's not making it very clear what contributions his co-authors are giving him, or whether they're agreeing or disagreeing with him.
Yeah. Yeah, one point, you were asking me to say something. Has anyone here looked at Tom Kuhn's Structure of Scientific Revolutions?
Oh, that's very famous.
Yeah, because it seems to me when you have like what they call them, like research programs, and it can either be progressive or regressive. But it seems to me it's kind of regressive now because you just have ad hoc patches on things. And then there's a period where they're competing alternative theories. And I think maybe that's where we're, at least with the dissidents in now. But there's no agreement about what's going to take over. And until there is some agreement, then you just kind of, well, it's kind of just a situation where it's not clear exactly what's going to happen. And the status quo always has a lot of inertia. It takes a lot to get people to change their minds. Sometimes it happens all of a sudden, and sometimes it doesn't.
As they say, this progress takes place one funeral at a time.
Yeah. Okay, so the crises in cosmology, calling this a crisis or crisis in cosmology, maybe that is an indication that there are some disagreements or an understanding that the current model isn't really working as well as they would like it to. And, so I guess they look at it as an opportunity for people to propose fixes. I think that's people are proposing fixes to the model, and I guess their objective is if we're successful with our fix, we get a Nobel Prize. But they're not really and looking at the fundamentals and saying maybe we made a mistake with the fundamentals.
That's right. That's what's ad hoc, which is sort of the situation I think is we're in right now. But hopefully things will change at some point.
It's going to take some piece of data that's going to have to make them go back to the fundamentals that they won't be able to ad hoc in.
I don't even know if that's possible, if they would ever change their minds, except only if there were just an overwhelming response from the public or other scientists that would sway their views.
Well, there's even a quote from Einstein that you don't work on the old.
Yeah, I was going to say it, but we got too involved in the discussion. And,
Robert was in the middle of a sentence. Go, Robert.
I was quoting Einstein that you don't work on the old generation because they're too set in their ways. You work on the younger generation.
Right.
Maybe they're more open.
That may be what they're.
He also quoted that his theories would not stand the test of time. Nobody ever points that out, but okay.
All right. Go ahead, Roger.
Yeah, it's a bit of a mystery, really. How did Einstein's revolution take over so easily? Because there doesn't seem to be any proper debate thing.
Well, I believe I can't remember who it was that was in opposition to Einstein's theory, but he passed away
A
right in the
lot.
middle of the I think with Bohr.
Mach.
No. There were a number.
But one of the major
Lorentz.
opposition person in opposition died right in the middle of that discussion. And
You have Ritz and you have Mach.
I mean, Rutherford was against Eddington, actually, but I mean he didn't die for more than 10 years after the 1919.
no, there was a major physicist that died right.
Lorentz?
Go ahead. Yeah, maybe it was Lorentz.
Or it could have been Poincare himself. Poincare.
Yeah, Poincare. Poincare,
Yeah,
that was the fella.
Yeah.
Poincare.
Well, they both never accepted it. I think.
Anyway, there seems to be no proper documentation about the scientist-physicist discussion whether they should go with Einstein's new theory or just modify what they got with Newtonian physics.
I mean, it is a concatenation of circumstances. You could write a book on it, and it's speculation. But certainly, there seemed to be something in the Great War, which is huge, millions and millions of people killed just in trenches and so on. And then we thought we'd become very civilized. War among civilized nations was a thing of the past, and we had this. And then after the war, well, maybe we get the two combatants, the British and the Germans, and we'll get them together. A German scientist got these new ideas, and the British scientist is going to verify it. And it came in at the right time, just a year after the end of the First World War. So you can start looking at things like that. It mightn't have happened in other circumstances.
Yeah, Einstein became famous, but he had a problem really that he was communicating with the British from Germany, so he could be looked upon as a traitor. And also the person in contact, Eddington, could be looked at as a traitor from his point of view. So suddenly, it's a big physics revolution, and it was a collaboration between British and Germans, despite their war being going on, making it look like, we could still communicate via physics and science. But it was really a bit of a scandal, I think, about there, which they sort of managed to cover up by saying, Einstein's a genius.
Science is kind of the Geneva of during war. I mean, not a lot of until war breaks out, but there are still communications between scientists during war, picking up on this or that, and it's not really.
There's supposed to be no communications,
especially if it's non-sensitive communications.
No, it's not supposed to be.
Not nowadays, but back then. That was kind of standard.
Yeah, we have the famous case of Bohr and his pupil Heisenberg, and they're on opposite sides. I mean, Heisenberg is obviously a patriotic German is he stopping the development of an atomic bomb? Well, probably not. He's helping them. And Bohr, well, Denmark is occupied by Germany, and so it's quite complex.
Okay, I guess
a lot of people think that Bohr did slow down the German production of a nuclear device.
You mean Heisenberg?
Sorry, Heisenberg. Yeah.
Yeah, it is suggested, but maybe that's after the event. We've made him into a nice guy.
Maybe.
Just
sorry, go Harry.
The V2 rockets, von Braun.
All right. I guess it's Jerry's turn he wanted to talk a little bit. He offered to talk. And I think we finished up with the cosmology discussion. Unless we have some additional comments or questions. additional comments or questions on the cosmology discussion? I think Jerry's going to talk about Big Bang Theory, I think. Is that correct, Jerry?
Yeah.
I just wanted to say cosmology is broken. That's all.
Jerry doesn't like the Big
We can
Bang
fix it.
Theory. And he's going to tell us why. And of course, I think the issue is this is the paradigm that the big idea, the big assumption that cosmological science is working from, but it's been modified so drastically with dark matter and dark energy and lots of other ad hocs that it's kind of hard to see whether it's still there or not.
Yeah. Are you ready?
Go ahead.
Okay. Well, I was going through my notes just because I knew we were having this discussion today, and I realized I had enough for just a quick presentation. I have way more written that I didn't go through, but I sort of highlighted these quick passages. Okay, here we go. It seems difficult to imagine that everything we've seen our whole lives, let alone the whole world and entire universe, was once concentrated into a minuscule pinpoint. How could we know this phenomena ever existed, since obviously no one was around to observe? Also, why the size of a pinpoint? Why couldn't it have been the size of a marble, a house, the earth, or even a galaxy? Actually, the pinpoint has been said to have had zero size and infinite density, two descriptions of qualification which seem quite logically inconsistent. How could something of infinite density possibly have zero size? And how could these effects even exist separately, with one concept of at a time, even way more possible, each at the same time? The Big Bang Theory was originated by Lemaitre. I don't know if I'm pronouncing his name correctly. However, his view of the universe could have started was quite different from what eventually evolved into the Big Bang as we know it today. From what I've read from recent sources elsewhere, often isn't as accurate as what I found in older books. The original hypothesis Lemaitre had set forth was that the universe started out as a primeval atom or cosmic egg, which would split and divide itself, similar to how an amoeba multiplies, until various celestial objects, planets, stars, and such were created to eventually harbor various kinds of life forms. When first hearing this, Einstein didn't think much of the idea, even though he had been known to say the universe is either expanding or contracting. However, he pictured these terms in a much different way than when he had first considered them. He theorized this since he pictured that a static universe and all the physical objects it contains, would inevitably collapse into each other with the effect of its own gravity. At the time, Einstein and literally everyone else didn't have any idea of the colossal explosion of literally everything, of a literal beginning of the universe by the initial singularity. He also had the idea of sort of an anti-gravity that pushes outward various celestial objects at a distance to prevent the universe from collapsing. He called this the cosmological constant. It wasn't until Hubble's law and after viewing the universe in outer space and seeing how everything looked as if it were rushing away that the Big Bang as we know it was originated. Since the time that the redshift and cosmic microwave radiation were observed, the Big Bang has been the most accepted cosmological theory for many decades. Eventually, even Einstein accepted it and considered the cosmological constant his greatest blunder. The updated version of the Big Bang had immediate problems and inconsistencies for which to account. For instance, according to the Big Bang, there was once a time where mass and energy and even time and space didn't exist. Such a state is completely impossible and even unimaginable. That there was nothing before that previously existed. The way the theory goes was that there was suddenly a tiny pinpoint, smaller than an atom, that appeared out of nowhere to immediately explode and create the expanding universe. What could have caused that, though? How did the pinpoint get there? And what caused it to explode? If there was indeed a colossal explosion that started the universal expansion, which sent mass and energy rushing out into every direction, What are the possibility the explosion actually occurred within a universe that already existed? If there was a beginning to the universe and the initial singularity did somehow pop into existence out of nothing, how much time was there after it spontaneously entered existence? Did it spontaneously explode? There is, of course, the idea of space-time itself expands and brings with it all the mass and energy that exists throughout the universe. This is seen as accepted as fact for many decades. My view is that space and time aren't physical. They're concepts to explain those inevitable conditions of reality. All physical interactions and phenomena, such as mass, energy, particles, waves, gravity, and light, occur within space. Space doesn't cause them or even interact with them. Space only serves as an empty medium, the void through which all the physical phenomena and their interactions experience their existence. If the universe is finite and expanding, there must exist unlimited empty space for it to continue to expand into. That is, if the outer empty space that encompasses the universe doesn't count as part of the complete universe. However, if the universe is infinite, how could it expand at all? At least two possibilities exist that could agree with the Big Bang if it is somehow accurate. One is that there is a limit to how far we could possibly look into the allegedly finite past, where the light of objects further out into space hasn't yet had time to reach us. The other view is that we can actually see to the edge of the universe, since the Big Bang implicitly states the universe is finite in space. What all exists past there? Nothing? Only empty space? If so, why isn't that empty space also part of the universe? It seems that the word universe quite often isn't properly defined. How could we possibly ever witness the beginning of the universe through telescopes? If there was somehow a beginning, will we see it in every direction? If that is what we'd observe, does that mean that what exists at the outermost edge of the universe, the same free particles which were released by the initial singularity, how could you see precisely the same thing, given that these particles couldn't exist in more than one place at one time? Okay, that's about all that I have highlighted. I have way more, but I don't want to just read haphazardly, so I guess that's about it.
So you're saying you don't really think that this thinking that that the universe began with a Big Bang really has any logical consistency at all? That's what I gather from what you're saying.
I haven't ever believed it. When I first realized that it was accepted within modern science, I was flabbergasted.
Well, I suspect there are a lot of other people. Okay, so this raises a number of questions. Do you have anybody have any questions? Want to examine what Jerry said? Clarify?
Well, I
Wow.
think he's encapsulated a lot of important questions, which all in one place, which is very interesting.
Well, one of the points. Okay, go ahead.
I was just saying thanks to Jim.
Oh,
Oh,
the point
Jerry's
that
got a lot of
me-
great questions. I mean, he's got an inquisitive mind for sure. And keep pumping the questions out, Jerry.
Oh, I appreciate it, man.
These
what
are a good
Jerry-
example of questions, which could be raised against this fundamental proposition. But they haven't been tolerated. Why haven't they been aired more, Jerry? And it's simply this authoritarian system. They would say, no, you may start asking questions like that, but you needn't worry. The authorities, the experienced scientists, the people who have spent a lot of money and a lot of money has been spent on this, they all say that this is the case. So you needn't ask these silly questions. Just, dismiss them from your mind. It's an example of how they've got rid of logical questions which really should be asked. Sir, certainly.
And you can't leave out, Ian, that they're wearing white lab coats and they look very authoritative.
Yes, that's a well-known phenomenon, Jim, indeed.
Well, I placed a comment in the chat, in the text chat, hence something from nothing. Lamontre, he didn't mean to unite science with religion, but his ideas of the Big Bang was in an agreement with his bias. That's all
Well, that's an interesting point. And I would think that Lemaitre, being a good Jesuit, would say that this process was created by God, that
Yeah.
God initiated this primordial, and that would be my view. I mean, he was a good Jesuit.
Yeah.
And I think he thought that his theory was an expression of God's will acting in the world.
And God created the universe.
I think there's quite possibly something in that, and we all have biases, and the origin of a lot of these theories, has been based on biases. However, what has flabbergasted me is that once something is accepted by the modern science, such as the Big Bang, it's accepted by Jesuits, it's accepted by fundamentalists, it's accepted by atheistic communism, it's accepted by all people of different hues because they're all subscribing to this orthodoxy.
Well, that's a point. I think the fundamentalists, if there are fundamentalists that are holding out, I think they get eliminated by virtue of that their opinion doesn't count. And but I still think there's some of them that are still holding on to their biblical opinions. But you're right, the rest of them are pretty much. It is kind of interesting as to why Roger did this thing about this guy who was critical of Einstein in China, and you may remember that, and that kind of fascinated me. They treated this the Chinese treated this dissident in China the same way that we in the West would have treated this dissident. So they're, completely different philosophy supposedly in China, but apparently not when it comes to the theory of relativity.
Science is a religion. That's it. Period. It doesn't allow for questioning of itself. And that's the same with the church, any church.
Well, that goes back to O'Rahilly's book, which is, as I introduced at the beginning, the point of his book is he's asking questions and challenging beliefs. And have you heard about O'Rahilly's book until our recent discussion yesterday? Anybody here? How many people have read O'Rahilly's book or heard of it?
Never ever heard of him.
Right.
That's interesting. Yeah.
Well, they just basically ignored what he had to say, right? Isn't that correct, Ian?
Yeah. They've ignored what he had to say. That is correct, Harry. But I would say also, and I take the point about the bias of all scientists and the Lemaitre origins and all that sort of thing. But O'Rahilly, who would be considered, according to modern ideas, as coming from quite a closed. I mean, you talked about the church a moment ago, Rick. There, a closed, pre-Vatican II church or something, and so on. If you read his book, it's totally liberal. It's totally open. As we quoted a moment ago, he said, authority has no place in science at all, and he
would have fit in with this group perfectly fine.
He would. Yeah. He would. Yeah, I'm sure he would. Yeah.
That's why James made a list of dissidents. He had that separate list of dissidents. It was Arthur Lynch, and Ian came in.
I was tickled. Yeah, I was tickled pink.
And we could expand the list.
You're blushing, yes. Ian. You're blushing.
Yes, my blush.
This book is intended to be an essay in constructive criticism. Existing expositions are freely criticized without regard for authority, which should find no place in science. So the question is that the operative philosophy of science today, or is that not? And I think our answer is, I guess my opinion, the answer is no, that's not the operative viewpoint of the way science is being done today.
That's right.
Agreed. That's 100% right.
And that's really kind of the reason why, and I really kind of laud James Arathoon. I had wanted to hear about O'Rahilly, and I wanted his presentation of yesterday. I've been waiting for it for quite a few months, and and hopefully we'll learn more. But obviously, O'Rahilly is a dissident, and he's criticizing the establishment, and the establishment didn't want to have anything to do with it. And their models are their models, and they're not going to change. And so we have crises in cosmology.
I think they dealt with it, Harry, by sweeping it under the carpet. I mean, they didn't want to come out maybe over the last 60 years and start challenging his ideas and so on. But they just swept it under the carpet as if it didn't exist. That's why so few of you know about it.
But
Right?
what specifically did he challenge?
Everything.
Exactly. I mean,
No, I meant EM wise.
EM wise.
Well, you have to read the book. It's a big, long, it's a lot of stuff. It's 900 pages, I think, right?
Well, just a few
908
examples.
pages of fairly turgid mathematics. But he has one statement in the middle of it where he says that the contention that the speed of detection of an electromagnetic wave, irrespective of the motion of the detector, that remains constant, not only appears to be, but actually is nonsense.
Okay, Jim, to answer your question, he is and if you go to Wikipedia, they'll say O'Rahilly favors the Ritzian theory.
Yes, I forgot to discuss that yesterday. That was an important point, Harry.
And so that would be, he says, but it is shown that the universally ignored alternative formula proposed by Ritz in 1908 is equally and even more successful. Even if Ritz's theory is not accepted, it has at least the merit of proving the unsoundness of most of the arguments adduced in favor of the prevalent view, which is Einstein's relativity.
Yeah.
So then he goes on, Einstein's use of Voigt's transformation, generally known as the special theory of relativity, is subjected to fundamental criticisms. That is, as regards electromagnetics, it is proposed to treat optics subsequently. So he's, in particular, Lorentz's local time and Minkowski's space-time are rejected.
Yes.
But Ritz has been too.
That's true. Yeah, that's true. And I would have.
O'Rahilly is saying he favors Ritz. What he's saying is O'Rahilly rejects Minkowski's space-time and Lorentz's local time. O'Rahilly is rejecting that. So, and he goes into that in his book. He talks about the Voigt transformation and the Lorentz transformations in his book.
Yeah, and he stresses that. He said, look, these are really Voigt transformations. And I think he says they're commonly termed nowadays Lorentz, but they originate with Voigt.
And then he goes on, if you're an etherist, he really sticks it to you. Contemporary discussion of the ether, in parentheses, is declared to be a mere logomachy, a waste of time. So he says theories of the ether are a waste of time.
And well, that all goes back to Michael Morley.
I'm just reading what he says here. And
okay.
I think he means the Constitution.
You asked the question, what's in the book, I think. Is that
okay? Okay.
Are we answering the question?
Yes. Thank you.
Then there's more. He goes into, he says, an elementary but radical exposition of the meaning of the symbols of physics is worked out. Yeah, that's really getting down to fundamentals. And then he goes into units and dimensions, which I guess would make Vladimir happy. And he talks about how units and dimensions are developed in electromagnetism. And, it's 900 pages. There's a lot of stuff
even the first chapter is actually an explanation of vector calculus. You know, if you're a bit rusty on that, he goes into that and all the various calculations.
Yeah,
You could actually have a look at the table of contents, maybe 2 pages, and it would show you, Jim, all the areas that he talks about.
Okay. How does he compare to McCullough?
McCullough. Yeah,
I was
McCullough.
kind of confused them. It's the little I know about them.
Well, McCullough was earlier. McCullough's 19th century. And
McCullough is the ether theorist. He's an ether theorist. And I don't know whether he talks about McCullough and
I don't know, but it's just that James yesterday did include McCullough in his list, but he didn't say much about him.
So he was Irish too?
Yes, he was. Yeah. You're pronouncing it correctly. I think James said McCulloch, but it's actually McCullough. You're right. But I think he was more at the time of Stokes, another Irishman.
But he wrote a big book too, right?
Indeed. Yes.
Well, there's a lot in here. You can, there's a section here on the ether, which he calls a logomachy, which means essentially something that's been ordained by law. I think that's what it means. It's, it's an assumption that, it just comes out of nowhere. It's just a fact. Talks about Voigt, Weber and Ritz theory. He talks about Helmholtz and Duhem. I mean, it's pretty.
I think that's the French physicist whose name I forgot. So you will actually see chapters named. One chapter is called Poisson. Another chapter is Ritz. Another chapter is, what you've just said.
Anyway, the point is that there's a lot of stuff in here. If you're an etherist, he's got a chapter on the ether. If he talks about relativity. The symbols of physics is really kind of interesting, where he talks about systems of units, and then he talks about relativistic units. Kind of, he's not really in favor of relativity. He's really highly critical. He's really critical of the way modern physics has evolved, I think. And, modern physics just kind of ignored that and continued on. And so it's like what Jerry was saying, we've got all these questions about, how this Big Bang thing can work. What does it mean that space is expanding? I mean, I think
maybe that's the mistake. Maybe that when they jumped on the idea that the redshift was a Doppler, because it seemed logical, or at least reasonable.
Yeah, there's been a lot of criticism.
It's actually observed in the rotations of galaxies.
Well, I mean that to explain
Doppler
it as
redshift, Doppler redshift does.
Oh, I'm not saying it doesn't exist, but the cosmological redshift is due to Doppler shift.
Right.
And that's as much of an ad hoc as that it's just proportional to distance.
Yeah, and that goes back to the work of art.
And in particular, why is this the amount of Doppler shift proportional to distance? That's ad hoc.
Yeah. Well, it goes back to the work of art and his work seeing.
No, it goes back before that.
Well, no, I'm just like, art proved that the redshift, them calculating the size of the universe through this redshift, is incorrect, because these quasars are close by these parent galaxies, and they say they're billion years away.
Now they're saying that quasars are always the center of a galaxy, so it's not necessarily. He didn't know that at the time.
The redshift is related to speed of recession as well. So
that's what Doppler shift is.
Yeah,
and then that became expansion of space, whatever the hell that means, because when they got up to beyond z=1.
But if quasars are local phenomena,
couldn't call that Doppler shift.
Yeah, but if quasars are local phenomena, then their picture of the universe is
Well,
incorrect.
my point is that, this Z equals 14 galaxy that has oxygen in it must have existed before the supposed Big Bang date, because it takes many generations of stars to generate oxygen. Uh, and
That's one of the quiet crises.
yeah, well, they don't call it a crisis. It's just that we got to adjust our model.
It's
Ad
a,
hoc.
it's a,
But if we just accept that redshift cosmological is proportional to distance, we don't know why, so it's just a hypothesis at this point, then everything falls into place. All this inflation and other crap goes away. And that's the mistake. That's the fundamental that has to be.
Their jobs would go away. That's the problem.
Well, but that's what I'm saying is reality. It needs to be promoted more, like Lerner and Louis Marmé. They're trying to. It's just as much of a hypothesis. And how about this for an idea? The cosmological CMB. If the universe really is many hundreds of billions or even trillions of years older than we think now, all those stars out there beyond the 13 billion light years have redshifts even greater, 15, 20, 100. And that's going to come to us as even lower frequencies, longer wavelengths, as the Z equals 14 microwaves. I mean, infrared. So that redshift essentially has been shifted down possibly to microwaves.
Which
and when
would
you add it all,
explain all of those.
and when you add all those frequencies together, you get the CMB.
Yeah, that's a good hypothesis. But just a quick word getting back to O'Rahilly's dissidence.
Sorry.
No,
I was just trying to get that in there.
Yeah, no, it's a very good point. It's a very good point. Yeah, it explains it. No, sorry, I thought we got the end. Just very quickly, had O'Rahilly written a 10-page book, which I think Franklin Hu said he would have preferred, very easy to read and so on, he would have been highlighted as a nutter, a crank, and it would have been, completely dismissed. But he's written this tome which people cannot understand. It's a very learned tome, and the fact that he's contradicting relativity and Minkowski and all that sort of thing has sort of been brushed under the carpet. It's a bit like, I think Macaulay said that his the historian Macaulay, his prose was written in such a learned tongue that if he brought in any matters of impropriety or any bad language, it wouldn't be understood by the ordinary people. So it wasn't, sanctioned at all.
Okay, going back to what Jim said, what are all these dots and stuff in here? I mean, it looks like there's something going on. I mean, why are these look like objects that are not really resolved in the distance in the microwave background? I don't understand why this microwave background looks like this. It's not uniform. It should be uniform. It shouldn't have all these variations in it. And they're claiming these variations are due to baryonic acoustic oscillations or some such thing. Variations in the Big Bang, but I don't. To me, that doesn't make any sense. These things don't look like acoustic oscillations. They look like objects in the distance that aren't really fully resolved.
Well, you should. Have you looked at Robitaille's video, Skyscraller?
I'm familiar with that. I'm just pointing out that what you're saying is an hypothesis that they're not considering that does seem plausible.
I would suggest it. Well, I mean, they're so set on their ways, and It's hard to think outside the box, I guess.
Well, the money flow is dependent upon, adhering to the existing paradigm. So if you adhere to the existing paradigm, and that's what determines the money. And people who adhere to the existing paradigm are considered good scientists. And you're not going to get any grants if you're not considered a good scientist. So
You can't even publish an archive.
Right. So it's a filter system that basically keeps itself going through its own self censoring.
Yeah, I've heard of this new. I just heard something of an archive called HAL. It's run by the French. Is anybody familiar with that?
No.
Let me give you some comment. You showed us picture of microwave background radiation, but these variations, it's only microkelvins. It's so tiny. And this is, from my point of view, this is an influence of macro objects in a cosmic medium, and that's it. And what is important, I read even some paper, they showed that the quality of our picture depends on the galaxies around us, close to us. And don't forget, we have even axis of evil. Remember, there is such axis. It's the influence of our own galaxy. That's it.
The solar
That's
system.
why don't over-evaluate these, changes in microwave background radiation, because it's microkelvins and some influence of macro objects. They are so far away from each other, but in any case, there is some influence of this. And axis of evil, it's influence of our own galaxy.
Our own solar system. The ecliptic.
Solar system, it's an ecliptic of the galaxy. That's why, yes.
Of our solar system, I believe.
You believe? It's okay. I agree with you because I explained this axis in this way. Thank you so much. In my paper, the last one, I told exactly this point, and I showed that plasma distribution in our solar system, it has a cylindrical formation, and then you have this influence on axis of evil of our own plasma around solar.
All right, we got 1 minute. Very little time.
Okay, that's why, guys, don't overestimate this. It's not some picture of some macro objects or all this stuff. No, it's our fluctuations because of the influence of macro objects in our world. And my main point, let me tell you, the standard model is absolutely wrong because it included infinities. All the infinities, infinite energy density, infinite our black holes, infinite space-time, and all this stuff.
Okay.
Absolutely wrong.
Let me interrupt here and say I want to thank everybody for coming today and participating, and we'll look forward to seeing you again next week. And I guess we got maybe 20 or 30 seconds to go. So thank you.
Thank you.
Thank you.
Thank you so much, all of you.
Thank you for organizing.
Nice to meet you. Okay. Bye now.
We got a few seconds to go. All right.
Bye, everyone.
Okay, bye.
Later. TTYL.
Glad to see Jim Morrison here. Morrison, I think he added some very interesting points to